Our robot is extremely powerful and very easy to control. Our specification was to design, construct and test a line-following robot, taking into consideration all the preference and mandatory requirements.
One of these things that makes our robot so incredible and so stable is that every step of our robot is under our control, and we test so many times to find the most accurate figures for our robot. First, when we choose stepper motor, the reason is that we think the stable is the most important thing that we need for our robot. Then, at the beginning of our project, the robot using 4 sensors can almost do everything on the track. However, when the track is cut short with large angle, we found that 6 sensors is the best choice for us, which can behave even more stable and better. We use interrupt functions instead of using delay, which makes our code elegant and logical. Making 2 motors controlled by different counters is the key point, which leads to the fast speed of our robot.
To organise our project, I decided on each team member's roles, dates of meetings and means of communication. During our initial report, we decided upon each team member's roles and responsibilities within the group. We decided that I would be in charge of designing and constructing the hardware. Alex would build the mechanical structure of our robot. Stanley would do the software and Edward was our project manager. We decided upon roles which best matched our own strengths. We held regular meetings every weekend to discuss the progress we had made during the week, what we still have left to do according to our time management and requirements, and to delegate tasks for each team member to complete during the week. Facebook was a vital tool when communicating with each other and sharing work, especially when completing both the initial report and the final report. If one team member shares a document, all other team members can view and edit this work. Every team member is kept up to date on all the project's progress.
Before we made our final robot, we thoroughly tested ideas to use a testing robot. This allowed us to ensure that everything worked in actual places before we made the final thing. We considered and tested many options for the material for our robots. Our testing robot was made simply out of perforated metal, and this allowed for the easy rearrangement of parts. One of the biggest challenges we faced was transferring all the components in the breadboard to the Veroboard. A new circuit layout needed devising, and every part needed solving in place. So we had to take the PIC, all the comparators, all the capacitors, and solder them onto the circuit board. Instead of the perforated metal we used for our testing robot, we used acrylic plastic for our final design. This was chosen as lighter, therefore allowed the robot to be faster, and also looked nice in the perforated metal. We had to use the workshop to do this as it contained the tools required to do the job.
Till now, there's still many things we can do to make our project better and better. Thanks to the journey on Coniston that I met my so great teammates. I'm here to appreciate all the great things that our group ever made. What makes me so proud of is that everyone during the project achieved something truly and learning the skills. So I made the video to show you all the fantastic things impressed us, and this is it. This is Group 17. Enjoy the video and see you on the Great Egress.